Hi, welcome to this module on statistics. In this video, we shall be talking about cluster random sampling. It's again one of the types of probability based sampling technique, cluster random sampling. How do we find samples out of population using this technique? You can see divide the population into groups, then randomly select the group from all the groups. As you can see in this example, in this pictorial representation, we have a cluster population and we have six clusters 1, 2, 3, 4, 5, and 6, and we have randomly selected two clusters out of it, which is cluster number 3 and cluster number 6. But the most important thing is, how do we form this cluster population? Now there are different steps behind it. Let's try to understand the different steps. The first step is defining your population. And imagine we have a population, but we don't have the clustered population. As in, we don't know which person falls in which cluster. We just have the population data. So we should always start with your population data to which we are intending to study, right? The second step is always dividing your sample into clusters. Now this is the most important part of the process. The quality of your clusters and how well they represent the larger population depends or determines the validity of your results. Ideally, there are some of the criteria that we, kind of need to create. Each cluster's population should be as diverse as possible. And there cannot be any repetition. That means if one person is a part of one cluster, that person cannot be a part of any other cluster. So each cluster should have a similar distribution of characteristics as the distribution of the population as a whole. Taken together, the cluster should cover the entire population. Imagine you have entire population 1 million records. Now you are creating clusters out of it. Cluster 1, cluster 2, cluster 3, cluster 4. Let's say cluster 5 and cluster 6. Now each cluster, let's say a person A is a part of cluster first cluster, he cannot be a part of any other clusters. And each and every cluster, if you combine them, that should make your population. Taken together, the cluster should always cover the entire population. Each cluster should have a similar distribution of characteristics as the distribution of the population. So ideally, each cluster should be a mini representation of the entire population. However, in practice, clusters often do not perfectly represent the population's characteristics, which is quite obvious. Now, if you're analyzing the people from Japan or Korea and you are creating clusters, you cannot guarantee that each cluster will be a replica in terms of characteristics or properties. They could be very similar to the population, but they cannot be a replica. So, in practice, clusters often do not perfectly represent the population's characteristics, which is why this method provides less statistical certainty than the simple random sampling. Because clusters are usually naturally occurring groups, such as schools, cities, households, etc. They are often more homogeneous than the population as a whole. So, after you have done with the step number 2, now comes step number 3, which is randomly selecting clusters to use as your sample. So let's say you already have 6 clusters created. Each cluster is kind of a representation of your population data. It is as diversified as your population data, not a replica, but somehow in the same direction, almost similar. Now we have to randomly select some samples out of it. So let's say we select sample this cluster and this cluster. So cluster 1 and cluster 4. Now these are going to be my sample clusters. So and then we get started with collecting data from these sample clusters and start analyzing them. So that is a pictorial representation of cluster random sampling. I hope you understood the concept behind it. That's all about this particular video. In the next video, we shall be talking about various other sampling techniques. See you in the next video. Bye bye.